you get an error. All right? This is similar to if you create an HTML page that doesn't follow the rules of HTML, like you try to stick in a tag that doesn't exist, you'll get an error. So if I go in here and type some kind of tag that doesn't exist, surprised I didn't get a warning message. Maybe it just ignored that. Let's go and misspell it. All right, I'm showing me an error here because I violated the rule. I don't have a starting and ending tag match because I misspelled the starting. If I put in an attribute that doesn't exist, again, at some point I should get an error because that attribute doesn't exist. Again, maybe I'm mistaken about this and it just ignores that. At any rate, there are predefined values for these things in every sort of XML file, and we'll see several of these XML files. In every one of these, you'll see certain predefined tags and certain attributes. These things here that are part of the tag are attributes, just like they are in HTML. In HTML, you have the href equals such and such. The href is what's called an attribute. It's additional information about the tag. All right, same thing here. Hey, we have an application. What's some additional information about that application? Well, the icon you find here. The label you find here. All right. So that's a manifest. All right. Manifest, again, typically comes in play when you're installing something. That's when it tells, it's sort of a way for the application to communicate some information about itself to the device that's installing it. Let's look at project properties here. All right. This specifies the target version of Android that are going to be used. So essentially the versions of the Android. This is automatically generated based on other properties that you've set. Again, it's generated by Android tools, so you can go in and change these values. All right. Let's look at this one. This is also, I believe, a generated file. The main one we're going to be focused on in this class is the manifest file. We'll see more stuff added to that as we progress. The properties, again, sort of when you define the project, that sort of gets generated, and so does the ProGuard. Now, let's look at some of these resource files, and I'm going to start at the top and work our way down. All right. Notice that I have 3 sets of images. All right, the images are in the Drawable folder. All right. And we can go and find this on through our file system. The folders in our file system match these folders here. So in our resources, here's the actual images. that correspond to the ones that show listed here. If you want to bring an image into your application, you simply go and drag it into the appropriate folder. Now, notice that there are three sets: HDPI, LDPI, and MDPI. All right. This is a tricky concept. I really had to stare at it a bunch of times before it finally kicked into my head. The HDPI, the LDPI, and the MDPI relate to screen density, not screen size. A lot of times people see HDPI and think they mean a giant screen. They don't mean, again, HD doesn't relate to the size of the screen. It's saying high density. You know, what's density? Is the number of pixels per inch. All right? So HDPI indicates high density. MDPI relates to medium density, and LDPI relates to low density. Let me get some exact numbers here. .240 pixels per inch is high definition. 160 is medium, and lower than that is low density. We have different icons for the different densities. And again, the nice thing about this is we define those icons, we put them in these folders, and the Android operating system automatically applies the proper one. Let's make sure we understand why this is necessary. Let's look at a very simple graphic. Let's say we have a graphic four by 4 pixel graphic that looks like that is a square. Oops. This is meant to be like a microscope view of a square. So, that's what the pixels would look like. In essence, this is what we're going to see. We're going to see a square. All right. Now, let's look at what happens when the pixels are more and less dense. All right. If the pixels are, let's say this is the medium density. If it's high density, that means that the pixels are really tightly compressed because there's more pixels per inch. If it's a low density, it means that the pixels are widely spread out. So there's less pixels per inch. So, that's how our square would look like on a high density display. It would look smaller. And this is what it would look like in a low density display. All right? We probably don't want that, right? If we have a phone that's a certain size, you know, we wouldn't want a high density phone to have a tiny little square, a medium density to have a medium square, and a low density to have a giant square. Would want them all to be the same size. So, how do you suppose we're going to accomplish that? We're going to specify 3 different images. A medium, a high, and a low. So if I want all these squares to be the same, on medium, low, and high, how am I going to do that? Well, the medium, let's say that's the baseline. That will stay as it is. The high density image, we'll put more pixels in. Instead of 4 by 4, maybe it is 8 by 8. And we have our square. And the low density, well, you can't really make it much smaller than 2 by 2, right? But yeah, we make it smaller. All right. Again, probably not having 4 by 4 pixel images. We're having, more pixels than that. So we make it smaller. The bottom line is what we do to accommodate the fact that there's so many different screen densities is we create different files for the different screen densities. All right. The more dense the pixels, the larger image it can display in the same amount of space. So if those pixels are really tightly packed, we can display more of them and still physically take up the same space on the screen. In fact, there's a simple formula for this. So usually you figure out a medium is like 160 pixels per inch or dots per inch. High definition 240, low's like 120. So if I had an image, let's say, that was 100 by 100 pixels for a medium density, I would make it 100 times 240 over 160, which is over 3 half, 1 half. I make this 150 pixels. And the low definition, I make 75 pixels. I'd use the same ratio of 120 to 160. Then all 3 of them would appear the same size on a high density, low density, and medium density. All right? That all look like 100 by 100 on a medium density display. So let's go back and look at our files.
Question.
Yeah.
So once you figure out, you have to, as a developer, you figure out the size, the pictures, pixels, and everything.
Right.
You put them in your resource
Right.
area. The operating system then
The operating system decides based on the density which one to apply.
So you don't have to code that.
You do not have to code that.
Now, in the old days, you had to always do that. So
Exactly, and that's the exact benefits of sort of this component-based architecture. You define the components, and the operating system knows to look for these certain things. Just like with languages, you used to have to code something for that to localize it. But here, yeah, very
I understand.
very cool environment.
Yeah, in the old days, you had to do that.
Yeah, the old days you had to do everything.
Yeah.
All right, so let's look in this case. In this case, we have 3 images, or let me rephrase that. We have 3 versions of the icon image. Let's bring up the medium density one. All right, it's that big, and if we look at the size of this, it is 48 by 48 pixels. The high density one, I would guess, would be 72 pixels. 72 by 72. Let's go and do that. And sure enough, it's 72 by 72. Why? Because the ratio of 240 to 160, 3 to 2, so it's going to be 50% more. The low density should be 36 by 36. And sure enough, it is. So, when we have our images, we can put different images in these different drawable folders. Now, this name I didn't make up, right? It needs to be drawable dash HDPI. That's known as a resource qualifier. That specifies under what circumstances this resource will be used.
Is there a tool, Mike, that allows you to develop the, can I call you Mike?
Yeah, that's fine.
Professor Zeller?
No, Mike's fine.
Okay. Is there a tool that'll help you when you draw a picture that get the, so that the ratios are already developed, you know, that they're always going to be the way you want them? I'm not aware of one. I mean, there's bound to be one out there somewhere. I mean, there's a lot of good tools available. I mean, I would just go by the proportions of the, you know, figure out what the baseline is for medium. The high will be 50% more, and the low will be 3/4 of what the medium is, I think, if I did my math right. So I would just, you know, I'd figure out how big I want the medium to be, and then I would just multiply it by those ratios. And that's how you develop? You go by the medium size, and then you make the...
Yeah, that's typically what I would do.
Okay.
Think of the baseline,
That's
and
cool.
then
That's a good key.
yeah. Now, notice that a couple of these aren't dependent on the resolution, so you'll get the same one each time. All right, same image each time. So regardless of whether it's on a high density, low density, or medium density, we get this version of these two images. All right, next. Another XML file, the layout. And the layout, again, can be viewed either in a code view or a design view. Let me double click on that. Oh, there's nothing really to this layout. That's why it's not showing anything. Let's look at the code view. Normally, again, you would see different, you'd see this, the layout here. I'm not really sure why it's not showing this. Let's look at the code view. Again, it's an XML file. So we have our declaration on the top. These things are simply comments. So if you see that, consider that to be a comment. All right. There's different kinds of layouts that you can have. You can make sort of like a table layout, you know, which is a nice grid. You can make a relative layout, and so on. This one uses a simple relative layout. All right. Associated with these are a variety of different properties. For example, Android : background, £, a bunch of Fs means that the background of that is going to be white. All Fs, standard hex code for white. Notice the ID, app plus ID, welcome relative layout, that associates and adds to the resource file an ID
become important when we get into our code, because our code is going to use those IDs to like find the different things in our layout and do something with them. All right. Now, this has 3 pieces to it, this layout. In fact, we can actually look at the app and see the 3 different pieces. All right. Notice the background of it is white. All right. There's a welcome message. This is a text. There's a little Android guy, and there's a little happy bee. All right. The text area for this is this text view. Image for the Android guy is this Android view. And finally, the image for, at the bottom, is the bug. Notice again there's different properties with this. The size of the text and so on. Notice these again. We're adding an ID to it so that this is the ID that's going to be used so that we can know to find it later on in our code. Let's look at the 2 images. All right. The source of this image is Drawable Android. All right. Well, what does that mean? Well, notice in our Drawable folder, Android. So that is going to be the image that's going to be put there. Likewise, the image down here is Drawable Bug, and so it will be that guy there. So we point to that through those IDs. So we don't have the file name, or I suppose in some sense we have the file name, but we have, again, a pointer of that. Now, if we had different sizes images for different resolutions, the operating system would automatically apply the correct one. Notice with the relative view, we specify how these things line up. We have the first one, then the second thing says, all right, put this guy below the text view, and then the bug image goes below the droid image. Things that are going to be on your screen are called views. All right, so there's going to be a lot of views on your screen. And they can be image or text or some other kind. Notice that in the text view, the last attribute in the text view is Android Layout Margin Top 10 DP. DP stands for Density Independent Pixel. Sometimes it's abbreviated as DIP. What does Density Independent Pixel mean? It means that it's the number of pixels that will be used to calculate the actual size based on the density. So 10 dp means that on a medium density screen, the margin is going to be 10 pixels. So on a medium density screen, the margin is going to be 10 pixels. How big will it be on a high density? Well, it will be 240 over 160, 15 pixels. On a low density, it will be 7.5, 8 pixels. All right. So it takes into account the density of the screen when displaying it. SP is similar to DP, but it's used with text. Typically, you are going to be using, you're not going to be using pixels, all right? You're going to be using DPs or SPs because you want to have those relative and adjusted based on the screen density. Again, if you use pixels, then your
your thing is going to look drastically different depending on the density of the screen. All right. Notice that this says that this text comes from @string welcome. Well, that's the last of our XML files, a string file, where we can define the different strings that we're going to use. So, for example, in that we said the string comes from string welcome, and therefore the message that appears is welcome to Android app development. Welcome to Android app development. All right. How did it know to do that? Because the layout said get your string from the string file welcome. And therefore it looks in the string XML file and finds the thing with the name of welcome. Again, this is where internationalization would come in. If I wanted to create a French file, I'd create a strings-fr, and I would put in the French equivalent. So if we do this, if we don't hard code any strings, but put all our strings in a string value, to internationalize our application would simply take this XML file, give it to someone that speaks French, and say, translate those words for me. All right, and they simply create a new XML file, and you don't have to touch the code. So it's very powerful for that sort of thing. I know this is a lot to go over, so this is meant to be sort of an introduction and a little instructions on how to navigate your way through Eclipse. So if this isn't all catching and kicking in, don't worry about it, because we will come, and we'll review these things a bunch more times. To kind of summarize where we're at, the manifest is information about the application that will be used when that application is being installed. So it just lets the person installing the application know certain things about it, and therefore they're informed as to what the capabilities of the application are and agree to them, and so on. The drawable folders, all right, indicate the images that you're going to use, and again are specific to the screen density. It's considered good practice to use different images, to use images based on the screen density. You don't want the icon to appear consistent. You don't want your icon look tiny if it happens to be displayed on a high density device. So that's why we have 3 of those folders based on the different screen densities. The layout XML contains the visual components of your activity. All right. And finally, the strings contain the strings that you're going to be used. We're not going to hard code any strings. We're going to point to them through this. Now, the last piece of this puzzle, which we'll look at, and we'll review this all next time, but we'll look at now, is the actual object, or class rather. And it's pretty simple, pretty straightforward code, not really any code to speak of in here. A couple things you'll notice is that this extends activity. We'll talk a little bit more about what extends means, but this is an example of an activity. And we have this onCreate method, and this is the method that gets fired up when this activity starts. So when we run this application and this activity starts, this onCreate method gets fired off, And what does it do? In a nutshell,